Hello! If you're preparing for the CCNA or a networking job interview, you need to know these 100 terms that I will cover in this series. I've divided it into 10 parts with 10 terms in each episode, so by the end you'll have a strong foundation in computer networking. But also check out my channel and subscribe for more videos. I also have the Networking Fundamentals playlist, so watch it if you want to go deeper into any of these topics. Okay, let's start right away. Number 1. Network. A network is a group of two or more connected electronic devices that can communicate, or in other words, talk to each other. These devices are, for example, computers, phones, routers, printers, and so on. The communication between the devices means that they can share data and resources like files, and they can access the internet. Without networks, computer would be isolated. Number 2. Node. A node is a device that is connected to a network and therefore it is a part of a network. So this could be one of the devices from our previous example, like computer, phone, router, printer, and each of them can be considered a node. And every node in a network can communicate with other nodes. Number 3. Host. Every host is a node, but not every node is a host. So basically not every electronic device connected to a network is a host. In RFC 1122 we can read that a host computer or simply host is the ultimate consumer of communication services. A host generally executes application programs on behalf of users, employing network and or internet communication services in support of this function. So what it means is that the host is the endpoint of communication, the device that actually uses the network and not just forwards traffic like a router does, for example. So your computer is a host, but a router isn't. Number 4. RFC. To explain what a host is, I quoted the RFC 1122. RFC in general stands for Request for Comments, and RFCs are formal, technical documents about how the internet technologies and protocols are supposed to work. They are official internet standards, and one of the most well-known RFCs is RFC 1918, because it defines the private IPv4 address ranges managed by IANA, and it's worth to know that. Number 5. IANA. IANA stands for the Internet Assigned Numbers Authority. I mentioned that the private IPv4 address ranges are managed by IANA. This is because it's an organization that is responsible for managing and assigning not only the IP addresses, but also top-level domain names such as .com or .org, and keeping the records of which organizations operate them. And also it manages the lists of protocol and port numbers used by various services. For example, HTTP uses by default port 80 and HTTPS uses by default port 443. Number 6. LAN. A LAN stands for Local Area Network, and as the name suggests, it's just a network of devices connected locally. It connects those devices in one physical location, such as building, school or office, and your home network is an example of a LAN. Your computers, smartphones, printers and all other devices are connected together to form a LAN. It is usually small, but it doesn't have to be. It can be also a large network if it's, for example, a company's office containing thousands of devices. At your home, your devices are connected to your router, which then connects them to the internet, while in a large RAN the devices are usually connected together via a switch, and then the switch is connected to a router in order to provide the internet access. Number 7. Switch. A switch is a network device that is used to connect multiple devices together within a local area network. You can think of a switch as the central point of a LAN. A switch is meant for switching, which is the process of moving data from one point to another within a network. Thanks to the switch, devices can communicate with each other efficiently while staying on the same private network, for example inside an office. A switch operates on layer 2 of the OSI model, and therefore it uses MAC addresses, which are the physical addresses of devices. It also works with frames, which are the units of data on layer 2. If you don't know what the OSI model is yet, or what MAC addresses are, don't worry, I'll explain that later on. For now it would be good if you remember that the switch works on layer 2, uses MAC addresses, and the unit of data that it works with is called a frame. However, there are also layer 3 switches which work with IP addresses, and they are capable of performing a simple routing, but they are also more expensive. Number 8. WAN. A WAN stands for Wide Area Network. It is a network usually much bigger than a LAN because it can cover a large geographical area. It connects multiple smaller local area networks together from different offices, cities or even countries. The best example of a WAN is the internet itself, which consists of millions of interconnected LANs together. Another example would be a company that connects its branch offices in different cities into one larger network. To achieve this, there are different technologies used, such as VPN, SD-WAN or MPLS. Don't worry now if you don't know these terms yet, I will cover each of them later on. And as I said, WAN is formed by at least two LANs connected together, usually it's more than two, and these LANs are connected together via routers. Number 9. Router. A router is a network device that connects different networks together. A perfect example is that your router connects your home network, which is a LAN, to the internet service provider's network, which then connects you to the internet. So the difference between a switch and a router would be that a switch works inside a single LAN and a router connects these LANs together and works between them. Its main job is to perform routing, which means that when we want to send any data to the internet, it needs to go through the router, so we send a unit of data, which here on layer 3 is called a packet. Remember, on layer 2 it was a frame. Here we call it a packet. So when we send the packet that contains the source and destination IP addresses, the router will look at the destination IP address and it will find the best path for the data to travel. This process is called routing, and there are two types of routing. Static, which means we add routes to the routing table manually, and dynamic, which means that the router uses routing protocols like OSPF, BGP, EIGRP or any other routing protocol to automatically learn and update routes. So what you have to remember about routers is that they do routing and they work on layer 3 of OSI model and they forward units of data called packets. Number 10. Gateway. A gateway is a device that connects two different networks together, just like a router does. So you might ask, what's the difference between a gateway and a router? And the thing is, a router can act as a gateway, but not all gateways are routers. A gateway is any device that is capable of connecting two different networks together, and this could be also, for example, a firewall. But most often, when you hear the term gateway, it will indeed be a router.